We continue with section 6.3 here, and here we will be doing some application problems. So we will still be finding the area under the curve, but now we name it as finding the probability using the normal distribution and normal distribution table. So there are many cases in which we can basically relate the area under the curve to the problem, and the probability is the same thing. So when we have to find the probability of some random variable being less than or greater than or between two values or outside those two values, we can use this normal distribution table. So you learned when it means to be area to the left, and so when do we take the area or calculate the area to the left of the of a z-score? Whenever you see these phrases, less than, smaller than, not greater than, not more than, or at most. Now remember, in probability or in here, the equal, less than or less than equal to, both will have the same answer, so same value, less than, equal to, or just less than. In the same way, when you see the phrase more than or greater than or not less than or not smaller than or at least, then it is the same thing as finding the probability of the to the right of the z-score, or the area to the right of the z-score. And you learned how to find the area to the right. You can look up the negative or the opposite of the z-score that you have, and just look up that one in the table. Or there is another way I will show you, and then area in between and area in the tails. Okay, so here example, find each of the following probabilities using the cumulative normal distribution table. So the first one is saying probability that the z is less than 1.45. Again, emphasizing z is less than, or if we had probability that z is less than or equal to 1.4, so they are same. And remember, in section 5.1 we saw that they are not same. If you include a value or you don't include a value, the probability can be different. But since this is a continuous distribution, the normal distribution is a continuous distribution, so excluding one point or one value doesn't change if we include that value. Okay, so here we are supposed to look at the area to the left because we see this less than sign. So here is the picture I have drawn for the normal curve. Now basically what you have to do, remember, is that in the center is your 0, on the right are your positive z-scores, and on the left will be your negative z-score. So you don't have to put the 0, just make a bell-shaped curve like this, and then somewhere on the right, again it doesn't scale, doesn't matter, just put on the right somewhere the value you have if it's a positive value, and then just look up the value. So when we look this up, we get this is equal to 0.9265. So how did I get that? Let me show you. So we have 1.45. Okay, so let's look at the tables. So we are going to look at the positive real z-score. Now if you notice here, these are the negative z-scores, so we are not looking here. So first column is telling you whether because these are the z-scores. So we go to the next one. Okay, we had our value was 1.45. So first two digits, 1 and 4, 1 and 4, or 1.4, that we will locate in the first column. And so we are going to read this line. So up till where? Because it was 4, 5, so we come down to the column of 5, and here is our value. So this is where my row and my column are intersecting. So 0.9265, this is the value, and that's the value I put in as my answer. So the next one, probability that z is greater than negative 1.37. Also, you should understand or know that when will it be less than, or when will be looking at the right or left. Also, you should estimate the what the area should be. So in this case, for example, because we are to the right, so the area must be more than 0.5. 0.5 is in the center where the 0 is, if we are looking at half the of the under the normal curve. Okay, so here we have negative 1.37. So we are to the left and we want the area to the right. So can you see it must be more than 0.5. So now if you look up negative 1.37, you will see that you get negative 1.3. So this is by row. If you use a ruler, it's a good idea. And 7. There is the 7th column. It is right in the here. The 3rd column is the 7. So 0.0853. That is what we get, 0.0853. But if I look at 1.37, 1.37. So I'm getting 0.9147. 0.9147. Or, so notice here that we can do this. We can say probability that z is greater than or equal to negative 1.37 is the same as probability z is less than 1.37. So that's what I was saying, that we can look at the opposite one. So it will be the probability, because we will just have to look up at the 1.37 for 1.37 in the table, and that gives us our answer. Or the other way was that this given probability, we can say this is equal to 1 minus the probability that the z is less than or equal to negative 1.37. So 1 minus, now when we looked at this probability, we saw that it was 0.0853. Now if you subtract, you will see that you get 0.9147. So both ways you can do it, either way. Okay, so the next one is probability. Now this will be between two values, and now both are positive values. So somewhere here, let me put 1.25, and this is 2.31. Now it becomes hard to write these, when you are make such a small bell curve and you don't have space. So I'm going to write it like this: 1.25, and this is 2.31. Okay, so we want this area. So what do? We first find, we are looking up at 2.31. So what will happen? That will give me the area to the left of 2.31, which I can write as probability that z is less than 2.31 minus, I will subtract the area of the to the left of 1.25, minus probability that z is less than 1.25. Okay, and why did I do that? Because remember, when I look up the area for 2.31, so let's say, so this is 2.31, so I'm getting all this area, but I didn't want this area. I don't want this area. Okay, so 0.37, looking at 0.31 gave me all this area, this one and all this, but I want to calculate out this or subtract this. And what is that? That is the probability that z is less than 1.25. So now So I say equal to, so looking up 2.15, you will get, sorry, first we will look at 2.31. That will give me 0.9938. And then I will subtract the probability that, or area to the left of 1.25, which is 0.8944. And when you subtract, you get 0.0994. That will be the answer. Now the next one, probability that z is less than negative 2.5. So less than negative 2.5, let's say somewhere here, and 2.5 to the right of 2.5, this one and this one. Now notice here these are the same values, basically opposites values of each other. So area to the left of this area will be the same as this area. So we can just say this will be equal to, we can do it the other way, or this is easier, 2 times probability that z is less than negative 2.5. So why am I not using this one? But in order to use that, to find that, remember we have to look up to the left or the opposite of 2.5, which is negative 2.5. So this is what we are getting. So 2 times. Now for this one, the area is, because we can expect it will be very small area, so 0.048. So when multiplied by 2, you end up getting 0.096. Okay, then we come to the next one, E. The probability that z is less than negative 4.01. Now if you go to the table, and we may look up this one as well. So this is negative 4.01 and this is 3.98. So let us see if we can find the values in the table. Okay, negative 4.01. Can you see the biggest number that we have here is this z-score, negative 3.49. Negative 3.49, that is our biggest number. So we don't have anything below that. Now at negative 3.49, our probability or the area to the left is 0.0002. So which means probability or the area to the left of negative 4.01, we can say it is approximately 0. In the same way, let's look at what is the highest number or the biggest number on that. So it is 3.49. So it is this number, 0.9998. Now this is closer to 1. So we go back and we say for this one that this probability is almost 0 and this one is almost 1. So sometimes these values, you have to just, you won't find them from the table, you have to know this. So for example, if I say what about probability that z is less than or equal to negative 5? So you can say definitely equal to 0. In the same way, if for example, here in this case, we ask what is the probability that z is less than, let's say, greater than, less than or greater, we can have. So if it is less than 4.5, so you will say this is 1. But if the probability says z is greater than 4.5, that will be 0. So these are kind of E, F, G, and this is H. So different examples. Okay, now there are word problems which have similar calculation. I will do that in the next video.